All right, my name is Chris, and this is Chia-Hung, and we both work at Google on Android OS, and we're going to give a talk about why you should use Scudo. So quick outline, we're going to talk about the history, design of Scudo, security features, performance and memory footprint, future works, and how to start getting involved in Scudo. So what is Scudo? So Scudo is basically a hardened memory allocator. Its name comes from the Italian word for shield, scudo. It essentially started life as the allocator from the LLVM sanitizers. This history is more from the Android perspective than everybody else. So as it was built in the sanitizers, it couldn't be used standalone. So the big problem was all you could do was build it, and it was so entwined with the sanitizer build that at some point we wanted to put it in other places, we couldn't. So there was a lot of work done by someone named Kostya, who took it and refactored it and moved it out and changed the build system and got it to build in a standalone way. In about 2020, Android 11, it got adopted by Android. So essentially it took a lot of time. We were trying to adopt it for Android probably a couple years before then, but in order to become a system allocator, it really required extra work and some more performance, less memory requirements. So it took until Android release 11, 2020, for the Google Pixel devices. That's the first time it was actually used in a real Android device. And for a while there, it was mostly in maintenance mode. So kind of we did it all, we put it in, and we just kind of said, okay, we'll make sure it doesn't break. But then in the last 2 years, we really spent a lot of time and investment, dedicated people working on Scudo to make sure that we improve its performance, improve its memory consumption.
Okay, and I would like to give the brief introduction about the design in Scudo, because we know there are a lot of allocators and each one has their own terminology or stuff. So we just want to give you a quick high-level design overview. And so in Scudo, there are 3 main components: primary allocator, secondary allocator, and the cache system. The primary allocator is the size class table-based allocator. So for each memory request, its size will be rounded up to the closest entry in the size class table. And here's a term called region. A region is used to manage the blocks with the same size. So depends on how the size class table is defined, we will have the same number of regions for the primary allocator. And yeah, it's just a one pointer allocator for each region, so it's fast. And the secondary allocator is a map based allocator. So as the name suggested, if there's nothing available in the cache, then you have to fulfill it with the system code. So it's slower than the primary allocator. And the third thing is the cache system. So it has the cache system, like other allocators, the exclusive cache, which is per thread cache. It also has a feature called shared cache. So it's faster than accessing the primary or secondary allocator, but it's slower than the per thread cache. The benefit of the shared cache is we are able to release the block cache in the shared cache. So it uses less memory than the exclusive cache. Another thing we want to mention is the proactive page releasing. So as we know, the memory allocator usually prepares several pages for different sizes allocation. And when those pages are not in use, it may not be released just in time, or you have to manually release it. In Scudo, we support a mode which will proactively release the pages for you. And in Scudo, we also support an option that dumps the internal Scudo status, and it includes almost all the details information with pretty easy readable form. and it includes some information like fragmentation info, your cache hit rates, or any region utility stuff. So I think that's a pretty useful stuff for understanding your program memory usage behavior. And as mentioned at the beginning, so one of the most important things for Scudo is security. It supports several security features, and we just list some most important of them. And the first one is the pointer randomization. It's in Scudo, it's unlikely to have two consecutive pointer allocation have the address next to each other, because we did some randomization stuff there. And second thing is the pointer quarantine. So for a freed pointer, it won't be reused in a certain period of time. And other things like double free or out-of-bound access detection, they are supported in Scudo. And one thing to mention is these checks are happened when the pointer is free. So it's not that powerful like other tools or stuff, but in the end, we have one stronger feature that called memory tagging extension, which is called short for MTE. It's a hardware feature in ARM v9, and it detects the invalid memory load and store it detects invalid memory access for each load and store. And it's also supported by Scudo. And then we want to talk about the performance and footprint, and we won't talk too many details here. So because we are working on Android, and Geekbench is one of the most important benchmarks that everyone cares. And so far, the performance is pretty close to JMalloc, which is the previous default memory allocator used in Android, and it's just the difference is less than 1%. And because of the security feature, we know the pointer randomization stuff, it inevitably consumes more memory at the beginning. Then we add many efforts to try to reduce the memory usage. And now I think the memory usage is pretty close to each other. And for some third-party games, it even consumes less memory than JMalloc. And there's some future works that we are still doing. And the first thing is we want to support more memory usage data, like the page utilization. This is mainly for large allocation, like 100 pages allocation. Because sometimes we notice that, only very few pages are dirty. That means maybe your program doesn't need that huge memory. And in terms of RSS, it's fine because you are not, you didn't dirty them, so you don't consume more memory. But in terms of allocator performance, it's better to request a smaller size. And another thing is we want to support a better recommendation system for defining the size class table stuff. And okay, the last thing and the most important thing, how do you get involved with Scudo? The first thing is if you have an Android phone or an emulator or something like that, you can just try the ADB command, the dump sys main info log stats for any apps or process. Then you will see the Scudo internal informations in the logcat, and you can read it and get some idea about what Scudo looks like. And the second thing you can try is if you have concern with the performance or memory footprint or something related to the real-time program, then you can try it only for developing or your testing. And it helps you to detect some memory bugs earlier. And you don't need to set up any like sanitizer if that's not an easy thing. And on Android, it's the default memory allocator in the Bionic libc. And if you are using the LLVM libc, then you've got it. And the last thing I want to mention is the configuration. So there is a allocator config.dev file. It contains all the allocator parameters. So when you are ready to create your own, please check it out. And yeah. And yeah, that's it, the talk. If you have any questions, feedback, feel free to reach out to us. Thank you.